Hello and welcome to Velocity. Today we're going to dig a little bit deeper into how all this tangent business that we've been doing can help in real-world problems. So the big difference today that you really want to be mindful of is the buzzword average versus the buzzword instantaneous. Average velocity is essentially the distance traveled divided by the time elapsed. Now, normally when you think average, you think about adding up all the values. The problem is there's an infinite number of x values in between here, so you can't literally just arbitrarily choose integer values in between to be able to calculate it. You have to use a little bit more advanced mathematics. So instead, we can take the change in the distance, which is going to be the up and down, divided by the change in time, and then we get the slope of the secant. That is for average. So average, you're basically just doing a slope formula like f of 2 minus f of 1 all over 2 minus 1. As opposed to if you move that distance really small, then it becomes instantaneous. Then the change in time is so small that it's negligible, and that's when you get the instantaneous change. So how do we know which one we want? Well, if you look at this screen, then we see that we can analyze Homer. He's going to run d feet in 3 minutes. He's going to then drive 5d feet in 30 minutes, because he really wants a donut. We're going to express Homer's average speed. This unit is pretty awesome because it kind of helps us stay organized. We're looking for feet over minutes. So in the first scenario, he moves d feet in 3 minutes. In the second scenario, he moves 5d feet in 30 minutes. What do we want to do? We just want to add them up. So he moved a total of 6d feet over 33 minutes. Or if you prefer, 2d feet over 11 minutes. And that is his speed in feet per minute. So it's a pretty straightforward setup. Those units really help us stay organized as to what we want. Alright, so now Nelson's taking us to look at a projectile motion problem. Now the idea here is that it's pretty much the same concept as the last problem. It's just we have this nice handy formula. This whole first sentence is really just describing this formula, so I don't really feel the need to read the first sentence. I've got a formula. Y is my height, t is the time. We're going to look at the velocity at 3 seconds. At 3 seconds means that we want to use our instantaneous velocity, which is going to be our old formula. So we've got our limit as h approaches 0 of 40 times 3 plus h minus 16 times 3 plus h squared minus, then we want to plug a 3 into that formula. So it's going to be 120 minus 16 times 9 all over h. We want to tidy that whole top up, come up with a formula, and then we've got our answer. It should be a lot of algebra, but at least we can get ourselves to the instantaneous rate at 3 seconds. I'll leave that for you to finish on your own. And now we get an alternative formula. This is another instantaneous velocity. If you find yourself getting confused easy, you never have to use this formula. I'm offering it as an option. Some students prefer this a lot more, other students never want to go anywhere near it. I'll let you decide which one you want. This is much like our limit as h approaches 0. In our h approaches 0, we're talking about the distance between the 2 points shrinking down to 0. In this version of the equation, it's slightly different. Instead of having h approach 0, you have x approach your target value. So in our last problem, our target value is 3, and we would have x approaches 3 and then set up the equation. Once with x, once with the number. The idea here is generally if you're a pretty good factor, this might mean less work. Let's see if we can try it in the next slide. Alright, so first thing they're asking for is the average. So average, I don't want to use this new handy dandy formula. I want to use pretty much our classic f of b minus f of a over b minus a. So f of 5 is going to be 26. Minus f of 3 is going to be 10 over 5 minus 3. These problems should not be hard, but you're going to probably occasionally get one wrong because you're just in a hurry to make it a hard calculus problem. But the buzzword here is average. When you get the word average, we just want to use the regular slope formula. Instantaneous is our calculus word. That means that we're going to need some sort of limit. Your choice, either limit as h approaches 0 or x approaches number. I want to try x approaches number just so you see an example of it. If you're not a big fan, you don't have to use it. So I'm going to say x is approaching my target number, which is -4. I'll write the first version with x's in it. And then I'll write my second version with -4 in it. So -4 squared is 16, plus 1 is 17. All over x minus -4. So you see the setup is a little bit different. It doesn't have that h on the bottom the way the other one did. And our algebra is going to be a little bit different too. We're going to end up with an x squared minus 16 over x plus 4. We can factor the top, and then we're going to be left with x approaches -4. The x plus 4's cross out, and we'll get x minus 4. Usually the number one mistake when students kind of dabble in both equations is getting confused and then taking this final answer and plugging 0 in for x. But x is not approaching 0, x is approaching -4. -4 minus 4 is -8. If you did it with h approaches 0, you will get the same answer. It's just a different kind of style. This one usually boils down to this factoring the top and then crossing out. All right, so again, we've got the average, buzzword, average, between -1 and 2. So we're going to take f of 2 minus f of -1 over 2 minus -1. Crunch that down, see what you get. For instantaneous, again, you've got the choice. You can either go h approaches 0 or x approaches a. I'm going to choose x approaches a one more time, just so you have some exposure seeing it. So the first thing we do is just plug in the equation like normal, and then we plug in -1. -1 squared is 1, plus 1 is 2, so it's going to give me 1/2. And the bottom I get x minus -1. One of the classic problems you should be comfortable with for the course. I've got fractions in my fractions. Whether you choose to do h approaches 0 or whether you choose to do x approaches number, either way you've got to deal with fractions in your fraction. So it's about the same amount of algebra. So you know that we want to multiply through by the common denominator. And then we'll be left with 2 minus x squared plus 1. That x squared plus 1 is in parentheses, all over a big mess. All right, so up top, I'm going to be left with 1 minus x squared, which will be 1 minus x, 1 plus x. The 1 plus x's will cross out, and I'll be left with 1 minus x over 2 times x squared plus 1. When I plug a -1 in now, I'm going to get a 2 up top, and then I'm going to get a 4 on the bottom. So it means my final answer is 1/2. All right, a particle. Mathematicians love particles. Moving along a straight line so that after t minutes its distance is that inches from the origin. So find the average. Find the average is basically just telling us that we want to use our regular slope formula. So that's f of 4 minus f of 2 over 4 minus 2. Plug 4 in the equation, plug 2 in the equation, and do all your algebra. It's going to be a little bit annoying because it's to the 4th. Instantaneous at 2 is going to be annoying either way you slice it, whether we go the new way or the old way. I'll do the old way just so they're both in the same lecture and you kind of remind yourself of them. The old way is 6 times 2 plus h to the 4th minus 6 times 2 to the 4th, whatever number that is, all over h. For this one, you'd have to take that 2 plus h to the 4th and expand it all out. That's either 2 plus h times 2 plus h times 2 plus h times 2 plus h, or you can use Pascal's triangle to expand that. Once you expand it, distribute the 6 through, and then see where it goes. I invite you to try and approach this one as having x approach 2, because it makes the algebra a little bit easier. You've got to expand an x to the 4th minus 2 to the 4th, but I think that's easier than expanding this out. All right, so here's a little bit more of a theoretical question. So in our theoretical question, we want to try and figure out, is the object moving faster at t sub 0 or t sub 2? Remember, its speed, or its instantaneous velocity, is going to basically be the slope of the tangent line. So if you draw the two tangent lines, you can see that at t sub 0 it has a steeper slope, which means it has a greater velocity. At the origin, the tangent is horizontal, which does that tell us about the initial velocity? If the tangent is horizontal, that means the initial velocity was 0. Sometimes we'll say that as v0, which means it started at rest. So when this whole thing got moving, it started from a stop position. It was not fired out of a cannon or thrown or anything like that. It started at rest before it started moving. Whether it's a person or it's a thing, I don't really care. Whatever it was, it started at rest. All right, so we got a position function, blah, 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 blah. Find the velocity and speed after 2 seconds. So 2 seconds, even though it says after, we're looking for instantaneous. It's almost the same thing as at 2 seconds. So we'd have to do our whole limit as h approaches 0, or x approaches number. And we'd have to say 2 plus h squared minus 8 times 2 plus h plus 9 minus whatever you get by plugging 2 into that. So let's just do 4 minus 16 will be negative 12, plus 9 is going to be negative 3, all over h. Once you crunch this down all and get a number, you got your answer. The only thing you got to be careful of is the difference between speed and velocity. Velocity is a vector, which means that it has a direction. The plus or minus is important to the velocity. Speed just has a magnitude, which means it's just a number. It doesn't have a direction associated with it. So if your velocity is positive, the two answers agree. If your velocity is negative, speed is the absolute value of that. And then that's your answer. All right, folks, I hope you enjoyed a little bit of Simpsons and a little bit of velocity mixed into your calculus. Enjoy the homework.